I'm going to review some stuff really quickly. The first thing we're going to talk about is radians to degrees. Did your teacher ever do this? I used to do this. I would take a piece of string and put it right here. Can you see where I just made that little blue line? Okay, let me. So I would go over this. Here, I'll go over in black down here. Go over this line right down here. And I'd make the string exactly that long. Okay? The radius. And then I would take that string and I would tape it around the edge of the circle until I got exactly that far. This radius and this distance are the same. Then the angle marked off here is called 1 radian. Okay, so it's when you go around the outside 1 radius. That's how big a radian is. Guys, it's just like you can measure how far from me to you in feet, inches, centimeters, millimeters, right? Well, you can measure in degrees an angle, or you can measure an angle in radians. It's just another way to measure an angle. Obviously, a radian is much bigger than a degree, right? Okay. The weird thing that happens is if you start counting these up, and I would always do this with my piece of string, and you get around here with your piece of string, and guess how much, what happens? It goes over 6 times. Anybody know what the little magical number over 6 something is? Almost three times took us almost halfway around. 3 of these radians, okay? There's a little bit past because it's pi, not exactly 3. All right. So going back to here, yeah, I think we get the idea. All right, so we need to convert if all the way around is 2 pi radians, that's equal to 360 degrees, right? But rather than say that, most of us remember, if you're thinking about that good old unit circle that we're going to have out here real soon, this is 0 and this is 180, but this is also pi radians. You remember that? Everybody got that? Okay. So the conversion we're going to use is that pi radians is equivalent to 180 degrees. So if we have 375 degrees, I just use dimensional analysis. I use this conversion right here. 180 degrees is equal to pi radians. So now I can cancel the degrees. Okay. If you have your handy dandy calculator, you can reduce this fraction on your calculator. 375 divided by 180, math, enter, enter. I don't know what it is. 25 over 12. Okay, so we just converted the angles to radians. Everybody good? Anybody know where that would be? If we started it at 0 over here and we went around 25 pi over 12, where we'd stop? What quadrant? It would be quadrant 1, because 25/12 is just over 2, right? Just over 2 pi. So it'd be all the way around and just into the first quadrant again. 375, yes? All the way around and 15 extra degrees. We good? All right. Negative 135, what quadrant should that be in, even in degrees? Negative, remember, goes this way. So we'd be over here in quadrant 3. If we want negative 135. All right. So we still would multiply by pi over 180 so that the degrees canceled. Don't forget the negative sign, though. This would be negative 3 pi over 4. Is that right? That's one of those special ones we're going to spend a lot of time talking about later. Remember the pi over 4s and the 45 degrees and the 30, 60, 90s, and oh, such fun. All right, moving quickly on. This is already in radians. So we need to use that same conversion, but we want the radians to go away. So what are we going to multiply by? 180 degrees over pi radians. Okay. Pi cancels, radians cancel. We have 180 over 3, which is 60. Can you do this one real quick? How did I do? Somebody get that? Because the 18 goes into 180 10 times. The pi cancels 103 times 10. And negative. Don't forget the negative. All right. Does anybody know what coterminal means? We're going to talk more about this tomorrow, but coterminal means it ends in the same place. Okay? It ends in the same place. So this is 90 degrees right here, but it's also called negative 270. Do you remember that? Okay. It also could be called 450. Do you remember how we find all those names? You could add and subtract what? 360. One extra rotation. So in degrees, talk more about this tomorrow real quick, but you would add and subtract multiples of 360 where n is any integer. So you could add 360 once, you could subtract 360 once. You could add 360 twice, and you'd be at the same spot on the circle. Are we good? Okay, what if it's in radians though? Yep, if it's in radians, you do add or subtract 2 pi n, where n is any integer. And I'm not going to make you write that every time, but you need to understand what it means. So can I add 1.5 pi? No, I have to add a whole rotation, which is 2 pi. Or I could take away 2 pi. We'll do a little bit more about that tomorrow. We're supposed to be working on some other stuff today. Find a positive and negative coterminal angle. So we could add 360 and get, anybody? 396, or we could subtract 360 and get, I don't know, negative. Thank you. All right, this one you'd have to add 360 twice before it became positive, right? Can I skip some of these? You get the idea here? You'd add 720 would make that into a positive, or you could add 360 and then add 360 again. What do you get? 315. And what was it the first time you added 360? Anybody do it once? One negative. Okay. Now, is that the only right answer for a negative angle that's coterminal with that? No. You could be really mean to Miss Hoffbauer, right? And subtract 360 like 10 more times and make it awful if it said any positive or negative angle. All right, what if it's radians? We're going to add and subtract what? 2 pi. Now, how can you do that on your calculator? Don't type the pi. So if you do 5/3 plus 2, math enter, enter, or you really should eventually get good at fractions, guys. The sooner the better. What is 2 is thirds? What do you got to multiply that by? 3/3, so you'd get 6/3. Yes? So I could have 11 pi over 3 or negative pi over 3. Did anybody do that? 5/3 plus 2 and get the 11/3? No? It didn't. You did it with a common denominator? Good job. But did somebody do it on their calculator? 5/3 plus 2 and it came out 11/3? And then 5/3 minus 2? Did it come out negative 1/3? Okay. So you can do it on the calculator, everybody okay? But you could also use a common denominator. Let's do this one with a common denominator. What would 2 be if it was over 9? 18/9 is 2. Okay. So what if I added once? Negative 22 plus 18 would be, oh, negative 4/9. That's negative. We'd have to add it again, right? What if we add another 18 to negative 4? Positive 14? All right. I'm not going to take your calculator away when we do that section, okay? The one thing you will have to do a unit circle quiz from memory without a calculator. All right, guys. SOHCAHTOA. Yes. Then you get the unit circle. Yes. All right, guys. Remember this SOHCAHTOA stuff? Opposite, adjacent, hypotenuse. You always have to start from a certain acute angle. All right. So what we're going to do, that's not it. All right. So what does SOHCAHTOA stand for real quick? Sine of some angle is opposite over hypotenuse. Anybody need to write this down, or you got this all in your memory bank? Adjacent side over hypotenuse. And tangent is what? TOA stands for opposite over adjacent. Do you know why this works? But do you know that every angle that has a right angle and a 37-degree angle is similar to every other triangle that has a right angle and a 37-degree angle? Okay. They're similar, right? They get bigger or smaller, the sides do. So therefore, the ratio of this over this is the same as the ratio of this over this. It's like a scale factor thing. How it can be programmed into your calculator. All right. That was a commercial break for why does this work. All right. This one says find the angle. Oh, we jump right into find the angle. Remember how to find an angle? Yes, you have to do the second button first. So for this angle, we're using little theta here. Remember Greek letter theta. From that angle we're looking for, this 2 is called what? An adjacent leg, and this 3.6 is called the hypotenuse. Anybody confused? Speak now. Okay. What uses adjacent over hypotenuse is cosine. So we are going to need to do the inverse cosine of 2 over 3.6. Now, we're going to go in degrees today, okay? So we need to make sure that our calculator is in degree mode. That is not the default on these calculators. Okay? So I'm going to go to my calculator, and I'm going to go to mode, and I'm going to make sure the third one down is in degrees, not radians. And then I'm going to go back to the home screen, and I'm going to type second button and then cosine, and then 2 divided by 3.6. And I get 56, and it says to the nearest tenth, so I'm going to write down 56.3. Everybody good? Which function would I use on the next one? From this little angle over here, I like to put a smiley face in geometry. From that little guy right there, what is this called if it's all the way across the triangle? Opposite, right next to where we're standing, but not the hypotenuse. So opposite and adjacent would be, so we would do inverse tangent of, opposite over adjacent, so it's 9 over 3.7. Somebody already got that one for me? 0.7? Thanks. All right. I'm going to go kind of fast from here on out because I'm hoping you remember this and I want to get to the applications of this stuff, okay? But these are asking you to find a missing side. From the acute angle at B, this would be opposite. This would be hypotenuse. So I would use which function? Sine of 64 equals opposite over hypotenuse. Now, this is the one that some people still mess up even when they get to Precalc. How do you have to type this in? Yes, 25.6 divided by the sine of 64. Anybody get an answer for me? Everybody agreeing it's 28.5? Okay. Can we just set one up and not solve it maybe? What does this one be? Opposite adjacent, right? So I'd have the tangent of 40 equals what over what? Be careful. Okay. And then I like to just put this over 1 so that I remember to cross multiply. I'm going to keep going, all right? Do we need to do some more of these? This one's looking for, from here, this would be adjacent in hypotenuse. Which one's that? Cosine of 60 degrees equals x over 17. Now 60 is one you're going to have to memorize eventually, but for today we could just type and get a decimal. It's what it's looking for anyway. But you would type 17 times the cosine of 60, right? Yeah, it's got a square root of 3 in it, so I can't do it in my head. What is it? No, it doesn't have a square root of 3. It's just a half. Oh, my brain isn't working either. Okay, over here, guys. Can I just skip a couple? Because we'll do some more of these. We're going to do them as applications, though, okay? Now, the reciprocal trig functions. You got to memorize these, guys. Got to memorize these. Remember, sine doesn't go with cosine. This co has to do with complementary, okay? The complement means it adds up to 90. Remember that? So the sine of 60 is equal to the cosine of 30. That has to do with the complement, okay? But the reciprocal, sine goes with cosecant, cosine goes with secant, tangent goes with cotangent. Remember this? Means you flip them over. I just remember that C goes with S and S goes with C, right? Cosecant, secant, sine, cosine. We good? All right. Find the cotangent of this angle. Well, we're standing over here. Cotangent is the flip of tangent. Tangent is TOA. So cotangent is adjacent over opposite, which would be what? We have a problem, Houston. What do we have to do to find this missing side? The most famous theorem of all, right? Pythagorean theorem? We have a missing leg here. So we have 6 squared plus a missing leg squared equals a hypotenuse squared. This is a famous one. 100 minus 36 is 64. So we get 8 for this missing leg. Anybody? Why don't we worry about plus or minus? Because it's distance. Can't have a negative. All right. Now we can find the cotangent. And it doesn't ask for the angle, guys. It asks for the cotangent, which means it wants a fraction. Okay. The cotangent is going to be adjacent over opposite, which is 8 over 6 or 4/3. When I said it's a famous one, do you remember 3, 4, 5 makes a right triangle? It's called a Pythagorean triple. This is the double of that, 6, 8, 10. Okay. It's not a concept error for sure. It's probably, if I'm just asking for this, it's probably no error. I would just reduce it on your paper, but yeah, it should be reduced. But okay, cosecant over here, guys. Well, that's the flip of what? Sine is opposite over hypotenuse. So cosecant, we need hypotenuse over opposite. We need opposite. This is another famous one. 24 squared plus some missing leg squared equals 25 squared. Now, is it 1? No, you can't just do 25 minus 24, right? You got to do the squareds and all that fun. Is 7, am I remembering right? Okay. So then hypotenuse over opposite would be 25 sevenths. Anybody lost? Okay. So this tangent is opposite over adjacent. We need this adjacent one. If I call that guy x, what's 9 square roots of 5 squared? Well, it's 9 squared, which is 81, right? Times square root of 5 squared, which is 5, which is 405. And then we have to do minus 18 squared. I don't know what that is. This comes out to be 81. So then this side is 9 when we square root it. So the tangent is what? Opposite over adjacent would be this is opposite because we're at this angle up here, right guys? Opposite, adjacent, hypotenuse. Everybody good? So it's just 2. All right. This one doesn't give us a picture. Can we draw the picture? Any way you want. Somewhere put theta. Make sure it has a right angle. What is secant? Flip of cosine. Cosine is adjacent over hypotenuse. So this is hypotenuse over adjacent. So 13 goes here. 5 goes here. Anybody know this one? Actually, do we even need to do this? Look what the question asks. So all we needed to do was what? Flip it over. Okay. They could ask something else, right? And we could have to draw it and find the missing piece. Yeah, unfortunately, I'm not smart enough to look. Just 5/13 because it's reciprocal of that. All right. This one do we have to draw? If we know this angle, we have opposite. Tangent is opposite over adjacent, right? 8, 15. We do Pythagorean theorem. Anybody? 17. So cosecant is flip of sine. Sine is hypotenuse or opposite over hypotenuse. So this is hypotenuse over opposite. Anybody? That's a lot of steps. And I'm going really fast. But do you think you could go through those steps on your own if you had to? Can I skip this one? Cotangent would be what? I don't know why I drew it like that. Cotangent is adjacent over opposite. If I square that, I get 11. I square that, I get 25. What's 11 plus 25? 36. Square rooted is 6. Secant is cosine flip. So it's hypotenuse over adjacent, which would be 6 over square root of 11. Some mean math person somewhere decided we can't leave it like that. We have to write 6 square roots of 11 over 11. Yeah. The joys of Precalc. Is that everything on that page? Okay, we're going to the next page. All right, on this page, they're going to make us find all 6 for fun. This is the disgusting one that they did for us at the top of worksheet 2. Is it worksheet 2? I'm on the right page. Okay. If you do Pythagorean theorem here, you get square root of 234, which we all know is 3 square roots of 26. Yuck. So then they put all these things in and found all 6 of them, and they're just disgusting. All right. Do you want to do 1 or 2 together? I don't care. 1 or 2. 1 or 2. I'm the eye doctor. We can do 1? Okay. Problem number 1. 10 squared plus 5 squared equals hypotenuse squared. That's 125, right? Square root of 125. Well, that's 25 times 5, yes? So it's 5 square roots of 5. Okay, here we go for fun. This is our angle over here. So can we label these guys? What's the 5 called? Adjacent. The 10 is called opposite. And this is hypotenuse. Okay, we're supposed to write down all 6 trig functions. Sine, cosine, tangent. Then when we flip them over, they're called what? Cosecant, secant, cotangent. Remember having to do this and you hated it? Yep, you'll still hate it. Me too. Okay, sine. Opposite over hypotenuse is 10 over 5 square roots of 5, which is 2 over the square root of 5, or 2 square roots of 5 over 5. Okay. Can you flip that back over, though? What was it before we rationalized it, guys? Was 2 over the square root of 5, right? So square root of 5 over 2. If we rationalize it from here, it gets really messy. It will eventually simplify down to this, but it's a pain in the neck. That's what I was going to say, neck. Okay, cosine. Adjacent over hypotenuse, which is 5 over 5 square roots of 5. These 5's reduce. Square root of 5 over 5. And this one, flip him over right here. Square root of 5 over 1, or just square root of 5. Oh, where we get to easy one finally, tangent. Opposite over adjacent is 10 over 5, which is 2, and the reciprocal is 1/2. I think 1 was enough fun on that, don't you? Okay, we're skipping 2. Number 3 is really the same thing, yes? You can do this using Pythagorean identities. I never do. I always draw. If I have sine, it means I have the opposite over the hypotenuse is 3 over 7. And then I do my Pythagorean theorem magic. 7 squared minus 3 squared would be 49 minus 9 is 40, which is square root of 4 times square root of 10, or 2 square roots of 10. Is that right? Okay. Now I'm supposed to find all the rest of these for fun, right? Ugh. Okay. Well, let's find cosine next. Adjacent over hypotenuse would be 2 square roots of 10 over 7, yes? Tangent, anybody? Yeah, it's 3 over 2 square roots of 10, right? Opposite over adjacent? Yeah. So we got 3 square roots of 10 over, what happens when we multiply by square root of 10 over square root of 10 here? This is 10 times 2 is 20. Well, okay. What happens when we flip them over? Sine is easy. What is it called, first of all, when you flip it over? Cosecant. And that becomes 7/3. When we flip this disaster over, we get secant, which is 7 over 2 square roots of 10. Square root of 10, square root of 10 becomes 7 square roots of 10 over what? 20. Okay. Cotangent. We're flipping this one over, but it's easier if you go back to the original. You look at this picture, tangent was opposite over adjacent, so this is adjacent over opposite, which is just 2 square roots of 10 over 3. Because remember, we had to rationalize. Here it was before we flipped it over and before we rationalized it. Then it gets, okay. One of those was more fun than I ever care if I have again. Are we good? Okay, you could do that one if you had to, yes? All right. What is this talking about? Right triangle stuff. Yeah, we're good. This is an interesting introduction here to a concept we're going to spend a lot of time on later. Second sine is called when we do second sine on our calculator and we see this, it's called inverse sine, or it's also called arc sine. Okay? Like a right angle, 90-degree angle are the same thing. Inverse sine, arc sine, same thing. We're not going to talk much about it now. All right. Huge issue on the quiz. Concept here. Okay. If you can't tell me where an angle of elevation or angle of depression goes, they are always made with a horizontal line. So when you do this, can this be an angle of elevation or an angle of depression? This is a somewhat vertical line, yes? Not a horizontal line. Can't be either one. You can draw this and say this is an angle of depression and this one is an angle of, and they are equal because they're alternate interior angles. Remember some geometry? They make that Z thing. Okay? But they can never be the angle with the vertical line. Does everybody remember this? Or I'm teaching you if you didn't. Okay. Can't be with a vertical line, ever. Okay, angle of elevation it says here. Angle of depression is here. Those little pictures are right off Khan Academy. They'll give me a YouTube copyright violation, right? Again, angle of elevation, angle of depression. Do you notice what kind of line it's with? Okay, so here's our questions. First couple don't have that word, elevation or depression, but Leaning Tower of Pisa is about 55.9 meters tall and is leaning. Okay, so if it was straight up and down, it'd be 55.9. So I'm going to assume that's this, okay? That's my Leaning Tower of Pisa. But its tip at this moment in time is only 55 meters above the ground. What is it angle it is leaning? So I'm going to say we want that angle right in there. Does that seem okay? Okay, what is the angle it's making with the ground? Which is not made very clear in the question, but I'm going to go with that. So what function are we going to use? Opposite and hypotenuse, which is, and we're looking for an angle, opposite over hypotenuse. Those are some bad fives there, Hofbauer. Looking like S's. Anybody got an angle for me? $79.7. Seems pretty tilty, huh? This is 90. 60's over here, somewhere in here. Okay. Submarine, 250 milliliters below the surface. Okay, so if we measure down to the submarine, I'm going to assume we're going to measure in a straight line down, right? So he's 250 down. Begins to ascend at an angle of 22 from the vertical. Okay. So he's going up. I'm not even going to attempt to draw a submarine. And here, I'll draw a fish. How's that? Okay. Here, with a periscope. Okay. 22 from the vertical. We never measure out for the vertical, but this says off of the vertical, right? How far will the submarine travel before it breaks the surface of the water? So where's the submarine's path? On our hypotenuse here, right? How far will the actual submarine travel? Okay. So the submarine was down here, and now he's up here, so this is his path. Okay, so what do we need to use? Adjacent would be this guy, right? Because this is our hypotenuse. So we need cosine of 22 equals adjacent over hypotenuse. So what do we type in on our calculator? No. 250 divided by cosine of 22. The hypotenuse, it has to be more than 250, yes? He would only get 250 if he went straight up. Okay. Answer, someone? 269.6 meters. Are we good? All right. I want to get to an angle of elevation and depression. We could make this one. They often say the angle of elevation from the bottom of the ladder, right? This one doesn't. It says with the ground. OMG. I still get pre-calc students who draw this triangle and talk about the ladder, and they put, this is my 10-foot ladder, Ms. Hoffbauer. That's not the ladder, okay? That is not the ladder. Okay, it says a 30-foot ladder that's here, as clearly shown in the picture, makes a 70.1 degree angle with the ground. How far up the side of the house does it reach? What function do I need? Sine of 70.1 equals opposite over hypotenuse. This time I'm multiplying 30 times the sine of 70.1. I don't know if this calculator's in degrees. I had 28.2. Reasonable? Should be less than 30, yes. How do I know it should be less than 30? Well, it should be less than the length of the ladder, but yes, the leg is always shorter than the hypotenuse, right? 28.2. What is the horizontal distance between the bottom of the ladder and the house? Now we need this side. Could we do Pythagorean theorem if we wanted? Or we could do cosine, right? Either one should give you the same answer. Might round a little differently. I got 10.2. Anybody else get 10.2? All right. Do we finally get to one where they use the word elevation or depression? Yes. If you ever need me to go back to a slide or slow down to color, I usually eventually figure out who's the slowest writer so that I can watch. We good? All right. This is a miserable question. And I made an extra copy of this for us so I could make it nice and big. Okay. Person standing 100 feet from the bottom of a cliff. Where's 100 feet? Right here. It says here. Here's the cliff, okay? Away from that is 100 feet. Okay. Notice there's a tower at the top of the cliff. Well, in this case, it'd be hard to miss because it looks like the tower is 5 times as tall as the cliff, but I don't know if it's trying to scale. Angle of elevation to the top of the cliff is 30. So, from his line of sight up to the top of the cliff only is 30 degrees. The angle of elevation to the top of the tower is 58 degrees. So from the ground or line of sight to the top of the tower is 58. Okay, how tall is the tower? Okay. Eventually, you could maybe use law of sines and cosines here. But even at that point, what we know is not anything about this triangle up here. Okay, so what we need to do is find something about which triangle? I think we actually need to find this side first. Okay, and you'd go with that. What would you have for that triangle? 100. This whole angle's 58, right? How do we find x? Cosine of 58 degrees equals adjacent over hypotenuse. So we type 100 divided by the cosine of 58. $188.7. Okay, I think now, I don't know why we found that. Does anyone know why we found that? No, I don't either. Rewind tape. Okay, let's try again. What do we want to know? Yeah, I think we need to find this whole height, and then we're going to find this little height down here, right? And then subtract the two. Okay, yeah, someone fix me. I'm broken, okay? Apparently I broke over a break. So we're going to go tangent of 58 equals x over 100. And then over here, we're going to go tangent of 30, right, in this little triangle, equals y over 100. And then if we subtract, we'll get the tower. Gotta speak up, guys. Don't make me sound stupid on the tape. 160, anybody get for this one? 57.7. So 160 minus 57.7-ish, about 102 point something. 102.3, depending how you rounded these other guys along the way. There would be meters, feet. Okay. Assignment. It's on the gold sheet. Did everybody pick up the gold sheet? Okay. It's a hot mess. It's a few problems off worksheet 3, a few problems off worksheet 4, and a few problems out of the book, which are the application ones, which is going to be on the quiz, yes? Miss Hoffbauer, yeah. Did I leave room for you to do it on 4B? Okay. On 4B, I left room for you to do the book work, okay? So you don't need a piece of paper, but you do need a book. Or a computer, or, okay? Any questions?